Today we're going to be solving rational equations. This is section 9.6 in the Algebra 2 book. When you are solving a rational equation, you're going to start by finding a common denominator for all of your fractions. Here we have denominators of 2, 6, and 6. So you want to think to yourself, what would be a common denominator for 2, 6, and 6? What's a number that 2, 6, and 6 all go into? Now you might think 12, but there's actually a smaller one. 6 is the smallest number that all three of these go into, so that's going to be our common denominator. Now look at your first fraction. The original denominator was 2, the new denominator is 6. What did we multiply by? 3. That's going to change that top to 15 minus 6x after you distribute that 3. The second fraction is going to stay the same. It's going to stay 4x plus 3 in the top. And the third fraction is going to stay the same. It's going to stay negative 8x plus 2 on the top. So the only fraction that had to change was the first one. Now once we have a common denominator, we go ahead and we cancel out that common denominator so we can continue to solve the equation for x. On the left side of the equation we have negative 6x minus 4x, which would be negative 10x, and we have 15 minus 3, which should be 12. On the right side of the equation we have it equal to negative 8x plus 2. From here we're trying to solve this equation for x. Get all of your x's on one side. We want to take the negative 8x and we want to add it over to the left side, giving us negative 2x plus 12 equals 2. Now we want to take the 12 and subtract it over to the left side, giving us negative 2x equals negative 10, and we're going to divide by negative 2. So final answer would be that x equals 5. Okay, take a minute and look at this next example. Try to figure out what the common denominator would be. Alright, the common denominator for x, 3, and 3 would be 3x. So looking at the first fraction, the original denominator was x, the new common denominator is 3x, we have to multiply the first fraction by 3. When we do that, the top gets distributed to become 3x plus 12. On the second fraction, the original denominator was 3, the new common denominator is 3x, so we're going to multiply that fraction by x, changing that top into x squared. On the third fraction, the original denominator was 3, the new common denominator is 3x, so we're going to multiply that fraction by x, and when we distribute on the top, we get x squared plus 1x, or just x squared plus x. You don't really have to put the 1 in front of the 1x. Now that we have our common denominator, we go ahead and cancel it out so we can continue solving the equation for x. On the left side of the equation we have x squared plus 3x plus 12, and on the right side of the equation we have it equal to x squared plus x. Now if you subtract x squared from both sides, they'll cancel out, and we're left with 3x plus 12 equals x. I'm going to subtract the 3x to the right side. 1x subtract 3x would be negative 2x, so 12 equals negative 2x. Now divide negative 2 to the left side, and we get a final answer of negative 6 equals x. This is our final answer. Alright, on the next example, our common denominator would be the product of both of our denominators, 7 and x plus 2. 7 and x plus 2. On the first fraction, the original denominator was x plus 2. The common denominator has a 7 with it, so we're going to multiply the first fraction by 7. That'll change that top into 21x. On the second fraction, we had the 7 originally, but the x plus 2 is the new part, and so we're going to multiply that fraction by x plus 2. That changes that top to 5x plus 10. On the third fraction, we didn't have anything in a denominator, so we're going to have to multiply by 7 and by x plus 2. 4 times 7 is 28. When I distribute 28 to x plus 2, I get 28x plus 56. That's distributing 28 through the parentheses x plus 2. 28 times x is 28x. 28 times 2 is 56. Now that I have my common denominator, I cancel it out, and I continue to solve this equation for x. 21x minus 5x would be 16x, and nothing subtract 10 would be negative 10. So 16x minus 10 is the left side of the equation, and it's equal to 28x plus 56 on the right side of the equation. From here, I'm going to get all of my x's on one side. I'm going to subtract 16x to the right to move those over to the right side. That gives me 12x. So negative 10 equals 12x plus 56. Now we subtract 56 to the left side, giving me negative 66 equals 12x, and we divide by 12 to give me a final answer of negative 5.5 equals x. On the next example, the common denominator would be the product of both of my factors x plus 8 and x minus 8. You might be looking at that third fraction and thinking about, well, what about that denominator? But remember that x squared minus 64 is x plus 8 and x minus 8 in factor form, so it just has both factors there already. Now, the first fraction already had the denominator of x plus 8. The new common denominator has a factor of x minus 8 that wasn't originally there. So we're going to multiply that first fraction by x minus 8. That changes that top to 2x minus 16 after you distribute. On the second fraction, we had a denominator of x minus 8. The new common denominator is both factors. The x plus 8 is the new part, and that's what we're going to multiply by in the second fraction. That top will become 3x plus 24 after you distribute the 3. On the last fraction, we already had both factors in our denominator, so nothing needs to multiply by 12. It's going to just stay 12. Now that we have a common denominator, we cancel it out, and we continue to solve this equation. 2x plus 3x is 5x. Negative 16 plus 24 is 8. So 5x plus 8 is on the left side of the equation, and it's equal to 12 on the right side of the equation. Solve for x. We subtract 8 to the right, giving us 4. We divide by 5, so x equals 4/5 as a fraction, or if you like decimals better, you can say 0.8. X equals 0.8. That's the decimal form. One more example, we're going to do a word problem. It takes Kayla 45 minutes to prepare 20 greeting cards. It takes Paula 30 minutes to prepare the same cards. Working together at this rate, how long will it take them to prepare the cards? We're going to set up a rate for each girl. Kayla's rate is 20 cards in 45 minutes, so her rate would be 20 over 45. Paula can do 20 cards in 30 minutes, so her rate is 20 over 30. 20 cards for 30 minutes. We're adding them up because they're working together, and we set it equal to 20 over x because we want to know that they can make 20 cards in x number of minutes. That's what we're looking for. Is what's x? How many minutes does it take for them to make 20 cards if they were working together? Now, we find a common denominator for 45, 30, and x. So think for a minute of what's something that 45 and 30 both go into. 90. So our common denominator would be 90x. The first fraction would have to multiply by 2x to achieve that common denominator. That's going to change that top to 40x. The second fraction would have to multiply by 3x to get to that common denominator. It's going to change that top to 60x. The third fraction already had the x. It's the 90, that's the new part. So we're going to multiply that third fraction by 90, changing that top to 1800. Now that we have a common denominator, we cancel it out, and we continue to solve for x. 40x plus 60x equals 100x, equals 1800, divide by 100, so x equals 18. Now 18 is your answer, and this represents how many minutes it takes for them to prepare the cards together. Notice how it's faster than each one of their rates because they're working together, so that they should be able to work faster than either one of them could work alone. That seems reasonable. Okay?